The height of a rocket is given by the function h of t, where t is measured in seconds since the launch and h is measured in meters. The acceleration is proportional to the cube root of the time since the start of the launch. At 10 seconds, the acceleration is 7 meters per second per second. What is a differential equation that models this situation? Well, how do we go about this? The first thing we need to do is we need to recognize that this is telling us that the acceleration of this situation is proportional to the cube root of the time. Remember, acceleration is the second derivative of position. And here we're given height, and that's the same thing as position. And we're given height as a function h of t. So the second derivative, what is that going to give us? That's going to be d squared h over dt squared. And so we know that that second derivative, d squared h over dt squared, that acceleration, and let me mark that maybe in a different color so we can see that in notation real fast, that is the acceleration of height. Well, what's the formula? It says it's proportional. Remember, when we see proportional, that means we're multiplying our constant of proportionality, k, times, so we don't know what it is yet, times the cube root of the time. So cube root of t. Now, one fact they tell us, I'll start writing this in yellow so we know what we're doing, is that at 10 seconds, the acceleration is 7 meters per second per second. What do we do with that information? Well, that tells us that we can replace certain parts of this equation. We can replace this with that acceleration they give us, which is 7. We don't know what k is yet, but we're about to solve for it. And then we know at 10 seconds, so that's the time, is when we get that acceleration. And so we're going to get that k equals 7 divided by the cube root of 10. And if I calculate that out, I'm going to do that really fast. Actually, I guess a little slower. I need to pull out my phone for this. 7 divided by the cube root of 10. That would give us 3.249. K equals 3.249. So now we can put this k back into our equation up here to get our final answer, which would be a differential equation that models the situation d squared h over dt squared equals k, which is 3.249 times the cube root of t. And this, my friends, is our solution.